Here's a pretty amazing technology, 3D printing. 3D printing is when various materials, often plastic, are joined together to build a three-dimensional object. It's done by designing the object on the computer with CAD software and ultimately exporting the appropriate files to the 3D printer. The technology is often used to create prototypes of products to be later manufactured in bulk. However, it can be used to actually create commercial product as well. And of course, there's a big market for the home user. I've seen people make sunglasses, chess sets, toys, you name it. Now, this is more of a professional device. And here we see a prototype of an engine, it looks like. So you have one example there. 3D printing can be accomplished by implementing one of a few processes, namely fused deposition modeling, or FDM, also laser sintering. Now, FDM is very common. That's an additive process where materials are fed into an extruder. They are superheated, and then they're applied on top of a substrate or build plate. And it's done layer by layer, ultimately creating the 3D shapes, which harden immediately. Laser sintering is a little different. That uses a laser that compacts a piece of material, such as nylon, using heat and/or pressure, and binds the material to create the structure. But FDM, very common in the industry. 3D printing is also known as additive manufacturing, and that name encompasses a lot of technology. Now, you might say, hey, this device, it's not really a printer, it's more of a modeler. And effectively it is, but you probably won't see that name, modeler or modeling, used too often because of the confusion it could cause with actual software-based 3D modeling when you're dealing with graphics. This device builds, this device manufactures, but the name 3D printing has stuck and it's commonly used. Now, what's important for the A+ exams? The same as always. Installing, maintaining, troubleshooting, and so on. You know the drill. Many 3D printers can connect via USB, Wi-Fi, and Ethernet. These printers are controlled by a computer running an operating system, such as Windows 7 and higher, or macOS 10.9 and higher. The computer itself should meet the minimum requirements or the recommended requirements for the various design software, like the computer-aided design software, the CAD software, and the slicing software if you're using it. Now, some manufacturers of 3D printers make their own software, while others use third-party programs. So be ready to install the different programs necessary and to even work with design templates, many of which are freely available on the internet. When first installing a 3D printer and periodically afterward, be sure to update the firmware for the device. Next, periodically make sure the build plate is level. And on cheaper devices, on home use devices, you could actually do this with a physical level, a tool. But on devices like this, you would do it from the LCD panel. So make sure that build plate is level, otherwise your object might not come out correctly. Then you want to lubricate, tighten, and realign the rods and the pulleys periodically. And of course, calibrate the device like other printers, but from a 3D perspective. More expensive 3D printers will have automatic calibration configured. That's becoming more common with the less expensive ones too. Finally, clean the device, including the extruder's drive gear. So we have the extruder here, and that's what actually puts out the filament to build the prototype or whatever you want to build here. And the gears are inside here, so you're going to have to clean those out once in a while. You also want to clean up the build plate, make sure that's clean of any residue, and so on. Clean out the device. Now, users should clean up after themselves when completing a 3D print job, but you and I know that this does not happen that often. That's a utopia, a perfect world that we don't live in, especially given the fast pace of engineering and prototyping work. So you want to be ready to clean up any excess stuff. Be ready to clean any of that excess filament from the device. Let's take a look at a few more 3D printers. Okay, here we have another MakerBot 3D printer, and MakerBot's big in the industry. And so this is another one here. You can look right in to see what's being built. Now, this is more of an expensive professional printer. And so with this type of thing, what we're interested in is the tech specs. That's what we want for this. So if we go to the tech specs here, we'll see the size and shape, the dimensions, the printing technology used, FDM. We could do 2-color. We have 2 print heads here. The resolution, the accuracy, product testing, the actual hardware, what it's made of, the LCD, extruder hardware, in case we ever need to do a replacement. Okay, color availability. And here's a good one, operation. What temperatures and humidity should you be operating the device at? And you'll see here that this has automatic calibration for the device, and the more expensive ones will have that. Safety and compliance software, MakerBot's proprietary, they use their own software. Other devices will use other software. And the file types that you can use, MakerBot, very common, STL, very common. Operating systems supported, electrical information, and the connectivity, right? So, and there's a whole, of course, there's a whole technical document for the device as well, written by experts. So you want to download that and go through it if you're working with any 3D printers. Here's another one, and a bit more advanced, HP Jet Fusion, large device, and this can do multicolor, and you can do all kinds of stuff with this. You open up the lid on the top, and you can build some pretty large prototypes. And again, multicolor. Some of these are just single color, some are 2, some are full color. And so another professional device. And here we have the DaVinci XYZ printing, and this is more of a basic device for home use, meant for doing one color at a time, quite often just white or black. And I have seen people make some pretty cool stuff with this, but more for the home use. So you're talking a couple $100 as opposed to several $1,000s for these other devices. So take a look out there at the different 3D printers that are available for the business and also for home use. Definitely understand, one, how to connect these devices, and also understand the basic maintenance for the devices as well.